Hello boys and girls, thank you for joining us again in this lesson. What we'll do today is follow up on the previous program that we created, which is the quiz game. We'll try and streamline some of the aspects of that program. As you saw earlier, we try to get it done and get it working very quickly without explaining a lot, right? I mean, part of the learning process is that you get your hands dirty, you create the program, and then you tinker with it on your own time. But afterwards you need to come back and look at the details and see where you can optimize, and this is what we're going to do in this lesson. So bear with me here, and I think it's going to be a really useful lesson. Thank you. Okay, so as you remember, this is the program that we wrote in lesson 3. It's called quiz game, so this should be extremely familiar to you. If not, please go ahead and watch the previous lesson. I'm going to put the link here so you can access it quite easily. All right, so this is our program. Let's run it again just to refresh our memories here. I'm going to open the terminal and go cargo run, and then it should ask me essentially 3 questions. Capital of France, Germany, and Spain. So this should be 3 out of 3. Would you like to quit? Yes. Okay, fantastic. So this is essentially the program that we wrote earlier. Let's try and explain what each line means, right? Okay, so let's start from line 1. As explained previously, we are importing a standard IO library that comes with Rust. So there's no dependencies so far, right? This project, we haven't put any dependencies. So if I go to cargo.toml, you will see that my dependency section is completely open. I'm just relying on what cargo comes with. All right, moving on. Now, at line 3 here, this is the main function. As explained earlier, this is the main entry point to any Rust program. Now, fn is the keyword on how to declare a function in Rust. The naming convention is that used what we call snake case. So if you had a function, a user-defined function that you create, it will be something along these lines, right? Snake case. So snake case essentially means that you're separating the each word by an underscore. Okay, good. So moving on, line 4, we talked about the println macro before. So macros are kind of special functions here in Rust. Line 5 and line 6, these are essentially, we declare the variables for the program. Now, Rust actually does infer the type of the variable from the value that you assign to that variable. But it is best practice, however, especially if you're writing kernel modules and system programs, to specify the exact type yourself. And the way to do that is you do colon, and then you give it a type. In my case here, they're both primitives, and they are both unsigned 32-bit integers. Okay, great. So let's continue with our optimization, right? As you can see, there are no comments in this program. If somebody picks up this program, they're really going to struggle. They're going to have to read it and try and reverse engineer what I'm doing here by reading the actual code. But let's put some textual comment. So the way to put comments here in Rust, there are a few ways, but the most common ways are // to put one-line comment. So in my case here, all I want to say is declaring program variables. Now, if I really wanted to have a more a bigger text essentially to explain what the program is doing, I could do /*, and this will give me a multi-line comment section. So in this case here, this is a quiz program created to learn the basics of Rust. Okay, and then the second line here, please subscribe and like. I know it is cheeky, but yeah, I gotta get there. Got this one in somehow, right? So okay, so let's close our multi-line comment here. Okay, so far we learned 2 things. We learned that Rust does infer variable types from the values that you assign to the actual variable. Of course, the best practice, as I mentioned earlier, is to give it an explicit type. So in our case here is unsigned integer, right? We also learned about one-line comments using // and the multi-line comments using /*. Right, let's move on. In the previous lesson I talked about arrays and I kept using the term interchangeably with vectors. Let's now define it properly, right? So as I mentioned earlier, arrays usually are fixed in nature, as in you can declare them and later on in the program you will not be able to grow or shrink that array. Vectors, on the other hand, they do grow and shrink, and they are a data structure in themselves, right? So if you're coming from that background, computer science background, you'll know about data structures, but this is probably beyond the realm of this lesson. So why did we declare questions and answers as vectors, right? Well, eventually you want to dynamically populate these questions and answers, right? So say from a database or from a text file, right? And maybe this is a good actually stretch exercise for you guys, okay? But let's say for argument's sake that this is the only questions and answers that you would ever give to a user of this program. Well, to be honest with you, there is no reason why we can't use arrays in that case, right? How would you do that? You'll just remove the vector, keyword, and this is it. You've just declared an array, one called questions and one called answers. Again, the type of the array is inferred by the values that I'm listing here. It might very easily be integers, for example, and the Rust compiler would infer from that, from those values, and turn that into integer array. Continuing with the best practice, let's comment our program. So at line 15, I'm just going to type in here declaring the question bank. Okay. And before we move on, let's try and execute this program. So we've made few changes already. At line 12 and at line 13, we've explicitly defined the type as unsigned integer, 32-bit, right? And then we moved from vectors to plain arrays. Okay, let's see if this is going to work. So I am going to bring up my terminal. I'm going to save here, right? And I go cargo run. Ah, look at that. So we do have an error. So folks, the best way to learn a new language or anything really is to troubleshoot, right? Get that brain working and see how you can fix it by yourself before you even look at the docs. Now, luckily, the compiler does give us really good error descriptions. So let's have a look at the first error here, right? So what is it saying? So it's saying that at line 20, right, type string cannot be indexed by U32. So let's look at line 20 here. So it's complaining about essentially this variable, right, which is declared at line 13 as an unsigned integer 32. Now remember that there is a slight difference in the way Rust index arrays and vectors and collection in general, right? It likes to use a variable type called usize as opposed to integer 32 or integer 64, right? It is a topic for a different for different lessons here, but the good thing is it does give you a hint, right? As you can see, it's saying slice indices are of type usizes, a range of usize. Essentially, if I now change this to usize, it should work. I think the easiest rule of thumb here, if you're using a variable to index an array or a vector, just use usize. Don't use an a primitive like an integer. Okay, so let's execute this. Let me just clear the screen. Cargo run. There you go. So it executed successfully. However, we still have a lot of warnings, right? I've got 4 warnings emitted here, and I need to get rid of these warnings, right? So for best practices, we are professionals here, so this is what we need to do. So progressing steadily, let's go to line 18 and do a brand new line there, and again use best practice and document your program. So I'm going to call this main body of the program. Now, if you recall, we tried to simulate an infinite loop using while true. If you're coming from C and C++, you probably have seen this type of infinite loop before. In fact, you might have seen it just as this, or as 4 and then 3 semicolons like that to do an infinite loop. Well, in Rust, we actually do have a great keyword, right, that will replace this while true infinite loop. And the Rust compiler itself actually is giving you hints on what to replace, right? So if I have a look here, it will tell me, hey, well, how about using loop instead, right? So that's the warning, okay? So it knows that you're trying to declare an infinite loop here, and it's asking you to replace it with loop. So let's do that. All you have to do is loop, and then that's it, and the curly brackets gets opened and at line 20. All right, let's save this. So we should see our count of warnings gets reduced. So let me clear that and go cargo run. There you go. So now got 2 warnings down from 4. Now moving on swiftly, we've declared our loop body here at line 20, and let's see what we have at line 21. So again, this is a mutable variable that will hold the answer that was typed by the user. Again, it is inferring from this statement here that answer would be the actual string type, but let's just put it in here, right? Just to be finicky about things. All right, so line 22 here, we'll just leave that as is, right? Essentially this would be asking the actual question, and then one of the warnings is we need to reuse the value that is returned from read line. At the moment we're not really using that value in any way, right? We're just grabbing the answer from the command line, from the terminal essentially, that the user has typed in, and putting that value into this variable here, which acts as a buffer, by the way, right? So let's do something clever, right? Why don't we hit 2 birds with 1 stone here and do error handling at the same time? Okay, so but before I do that, let me just hover on read line here, and you will see what it is actually returning. It's returning a result, right? And result is again a special type, and you will encounter this quite a lot in Rust, right? But for now, let's not explore the extent of what this return type gives us, and let's do some basic error handling here. And you can do that with the correct value. Essentially, it will try and read from the terminal, and if it fails for whatever reason, this is the error that we are emitting to the terminal. Okay, and of course our warnings that you see here, they are actually in 2 places, at line 36 and at line 23. So 23 and 36. So let me just copy and paste this, and of course line 36 here is the line where I am asking the user whether they want to quit out of the program. Okay, let me save that and try and recompile it. So technically I should not see any warnings right now. There you go, and the program executes successfully. Okay, continuing with our optimization here. Line 24, let's see here what we have in line 24. So I am comparing the answer that the user has just given me against the answers array that I have here. But if you recall, for the eagle-eyed amongst you, if you type in, for example, Paris as an answer in lowercase, it's not going to work, right? Because it is, this comparison, it is case sensitive. So one suggestion here is to maybe make everything to lowercase, right? So let's put all the answers here to lowercase, and same with this one. Okay, so that way what happens is that regardless of how the user types their answer, as long as of course the character values are exactly the same, you know, you shouldn't have a problem. So if they were to type it all in capital letters or all in lowercase letters, this condition at line 24 would always be true as long as the Paris word, for example, was typed in. Okay. Again, moving on, line 25 is fine, line 26 is fine, and 27 to 29 is also fine. So I'll tell you what, let's pause here again and execute the program just to make sure that we are on the right track. So cargo run, right? And in here, I'm just gonna do Paris all in lowercase, okay? And then I'm gonna, in fact, put everything in lowercase and see. I should see 3 out of 3 correct answers. There you go. Quiz finished, result 3 out of 3. Line 30, we're essentially just incrementing this index variable of type usize, if you recall, right? Line 31, we're just comparing our current index against the length of the array, just to make sure we don't have an index out of bound error. If it is greater or equals to the array length, then we reset the index to 0, and this is at line 32 here. We're kind of refreshing the answer variable. Again, there are better ways to reuse a variable, right? There is the concept of shadow and all that kind of stuff. Again, probably a tutorial for another day, but for now, just think that we are resetting this answer variable. That is the easiest way to explain it. So remember, folks, the key here out of these tutorials is that you are operational. You can write programs. You don't need to understand this in depth just yet. For now, just get your hands dirty, get programming, and the rest will come, right? Okay, so moving on again, line 34, 35, we're just inputting our scores here. And then at line 35, we're asking the question, would you like to quit, right? Again, line 36, we've kind of added an error handling here, right? With the expect function, right? Line 37, let's do the lowercase thing again, just to make sure that whichever way the user inputs it, it will work, right? In fact, let's give the user a few options. They don't just have to type Q, right? They could maybe type, let's actually make it more interesting here. Let's get him to type yes, get him or her to type yes, okay. Or, now, this is a new, you should be familiar with this, right? This two symbols here, these two pipes, is essentially or, right? So we want the condition to be if the user types in yes, or let's just pick another keyword, maybe just buy, right? Then we can go ahead and quit. Okay, let's save. Let me clear the screen quickly and do cargo run, and then enter, enter, enter. Would you like to quit? Yes. There you go. Okay, so let's do a final improvement here to the program, and let's take a look here. What can we modify? All right, I'll tell you what, let's modify line 37, this condition here that checks for whether the user typed yes or buy to quit the program, right? So Rust offers you a multiple way to do these conditional checks. There is something called pattern matching, and it is probably something that you haven't seen before. It is very Rust specific, but if you know what switch is, if you're coming from Java or C or C++, there is the switch statement. This is more or less similar. There is, of course, a lot more to it than what I'm describing here, but again, read the docs. For now, let's try and use this match expression to replace this conditional statement from line 37 here to line 39. All right, let's get started. So in terms of matching, I am just gonna type in the keyword match, and I'm gonna come in here and get my statement that I want to match against. Now remember, if I go to lowercase function here and I look at the return value, sorry, the return type of this function, it is a string. Okay, the pattern matching here in Rust does expect string literal, str essentially. There is a slight difference here, difference between the string type and the str literal. Again, this is a big topic and probably worth an entire lesson by itself. So to make things easy, I am just going to cast it, or essentially convert it into a string literal. So if I just hover over this, it will tell you that I am returning an str. Okay, now what do we need to do here? I need to grab this string literal here. Okay, so we have two choices, right? Yes or a by. So that pipe is essentially is or. Okay, and then you do the what we call the fat arrow here, and if this matches, then we want to break, comma. Now our catch-all statement, or the equivalent of a catch-all statement, or default condition here, condition statement similar to switch, is underscore. Right, so this will catch anything that is not yes or by. So essentially, if you just type in a random character, just type in enter, it will continue. And let's give a nice message here with the println macro saying you chose to continue. Okay, so I think that's all we need to do. Let's delete line 41 to 43. That's our previous condition using if else. Let's try and compile it and see what happens here. There you go. So let me try this again. Would you like to quit? And I'll go yes, maybe with a capital Y there, just so you can see that the two lowercase is making a difference. And there you go. It exits the program. Fantastic. That's pretty much it in terms of modification. So now if you compare this to the previous program that we learned in lesson 3 and we typed together, there is a huge difference, right? We used some of Rust peculiar yet very useful functionalities. We played with vectors, array, we explicitly and strongly typed the variables like what you see here. We talked about the difference between an unsigned integer new size and why in Rust anywhere where you see arrays or vector or any collection, really just use usize for variables. We talked about the infinite loop, that there is a specific statement for that, and it's the loop keyword here. We did some error handling with expect. And finally, we try to play with some match expression. Finally, here is a side-by-side comparison. On the left-hand side is the program as we wrote it in lesson 3. On the right-hand side is our program that we wrote in this lesson. And you can see that it is slightly different, a little bit more professional, and uses Rust's inherent functionalities. Okay, so thank you everyone, and I will see you in the next lesson.